Purpose of this talk: what new practices should we adopt to improve the rate at which we learn reliable, useful knowledge about how to develop software? The two key things are faster development and more reliable knowledge. This book starts from these two books. One is The Sociology of Philosophies, a Global Theory of Intellectual Change by Randall Collins. So that's a sociology book about philosophy, and Theory and Reality by Peter Godfrey Smith, which is a philosophy book about science. So, just going to get started. Collins starts his analysis of intellectual work and intellectual change with what he describes as interaction rituals. So an interaction ritual is two or more people physically assembled. They all have their attention focused on the same object or action, and they all know that that's what they're doing. This book was written before physical or video conferencing was widely known. I don't know if he would consider a video conference an interaction ritual. Most video conferences I'm in, you can't actually tell if the people are focusing on the same thing I'm focusing on because they've got their camera turned off and they've got their voice muted, so they could be doing anything, and most likely they're not paying attention. So probably an interaction ritual requires physical presence, and the group shares a common mood or emotion. So typical example of an interaction ritual would be a worship service at some sort of place of worship, or a bunch of people sitting in a bar watching the World Cup on television, or mob or pair programming, because they share all of these attributes. That's one of the reasons why mob programming or pair programming feels so much different than solo programming, even though the end goal is the same. It's because, one, you're conducting a social ritual, the other, you're just by yourself. Now, what Collins says is that when it comes to intellectual work, the key intellectual interaction ritual is what we're doing right here. So you have a group of people physically present. They're attending to a single thing, me, and the ideas I'm saying, and they're conducting an analysis, or you are all judging whether the things I'm saying are correct, useful, so on and so forth. Now, we could be a pair of people debating up here, but that would be the same sort of intellectual ritual. And as a speaker, as probably most speakers knows, it's very common for the whole group to have a common mood, especially if the talk is going really badly or the talk is going really well. You can definitely feel the common mood among the talks, so among the crowd. So what Collins does is he builds off of this to work out how intellectuals work. What sort of emotions do they get at events like this? What sort of ideas do they get? What sort of motivations do they get? And what do they take with them when they go away back to where their home base is and do what intellectuals do, which is primarily writing things that get distributed in some sort of ongoing, slow-paced conversation about ideas, and then they go back to the next iteration of the intellectual ritual. So Collins develops this at some depth. I'm not going to go into all the details because there's maybe a somewhat simpler metaphor that captures this well enough, and that is the music scene. So these are pictures from the heyday, the early heyday, the first wave of punk rock, which was, I think, 1976 to 78. There was a punk rock scene. And I think of that as an intellectual ritual extended through time. So there are people at the scene. There are people who are in the scene and they know other people are in the scene with them. So could be talking about musicians, could be talking about fans. Both of those groups of people make up the scene. What other characteristics was it supposed to have? They're all focused on a single thing. In 1976, these people were focused on a kind of music that had not yet gotten the name punk, but they knew there was that thing. There was, so I'll do my Portuguese wherever you went. This is embarrassing. They had Nossa Coisa, our scene, our thing that we're working on. A similar thing was true of the early days of Agile, which I might off the top of my head put like 1999, or the Agile scene. There was an Agile scene from maybe 1999 to maybe 2003, and it had that same character. There were a group of people who knew each other. We were focused on this thing called Agile, not before it had the name Agile, which only came in 2001. So that was Nossa Coisa, that was our thing. And in both cases, punk rock and in Agile, there was the feeling of having a common emotion. Here is a quote from someone who is at the punk rock scene. My heart would be racing every time I walked to CBGB's. That was a really core club in the New York punk scene. And then the doors would open and I'd be there. I was so excited every night I went. Everything was new, and it was so exciting because I knew I was walking into the future. That's the same feeling, I think, we had in the earlier days of Agile. Like punk rock, it sort of declined, scenes end, the Agile scene is kind of over, but those of us who have experience in a scene, and I've been involved in maybe 2 or 3 software scenes in my career, there is that energy that you always want to get back. And so part of what I want to do here is get that feeling back from you. Okay, now the musician Brian Eno, who has been involved in various scenes, coined a word called scenius. And scenius stands for the intelligence and the intuition of a whole cultural scene. It is the communal form of the concept of the genius. Individuals immersed in a scenius will blossom and produce their best work. When buoyed by scenius, you act like genius. Your like-minded peers and the entire environment inspire you. The important point that I want to make by using the word scenius is that something like Agile doesn't happen just because Ward Cunningham and Kent Beck are lone geniuses floating around inventing things by themselves, any more than the Sex Pistols and the Clash, and that the other picture was the Ramones. They didn't operate in a vacuum. Genius, most of the genius that changes the world comes from a scene, and it's through the mechanism of genius, which is nice for those of us who are not geniuses because we can still contribute by creating the scenius. Now, as Collins would have predicted, Agile as a scene had at its center 2 conferences that at its very beginning had 2 conferences. Later there were a couple more. They were the OOPSLA conference and the Pattern Languages of Programs conference. And that was the place where people in the scene got together and produced the scene, figured out what to do next, what problems needed to be addressed, how to move forward. And so my first recommendation, the recommendations are in green, is that if any of you are running conferences, that you ask consciously, is there a scene that this conference can be or is fostering, generating, is fundamental to? I'm not going to give advanced advice about how to run conferences, because the only conference that I was really involved in running was kind of a disaster. And actually, there was this workshop I ran that was definitely a disaster. So don't do what I did in those two cases. But I will make one suggestion. The OOPSLA conference had a particular kind of pre-conference workshop that followed a particular ritual, and it was, in my opinion, important to the generation of the scene. I'm not going to talk about that because of time, but if you're a person interested in running a conference, I would like to talk to you about that, and I would like to offer whatever help I can have to whatever people want to have such a scene or such a workshop. Okay, I'm going to switch to science now. In 1948, this man, Kelvin, Lord Kelvin, published a paper whose claim was that there is an absolute lower bound of temperature that you can achieve, an absolute zero. Which is not an obvious thing, and he justified this claim in the usual way through a series of experiments. In the case of this experiment, the variables that were controlled were volume, temperature, and pressure. This isn't his original data. This is some data that I pulled off the net by typing in Kelvin's experiment. And you can see it's plotting volume against temperature, and each one of these lines is the data at a particular pressure. And you can see the lines, the data points aren't exactly on the lines, which is typical of experiments, but if you extrapolate these lines down, you find that they reach the 0 point on the y-axis at a particular value, which by an amazing coincidence happens to be 0 degrees Kelvin. And this was a significant enough result that he got to have his own temperature scale named after him, like Celsius and Fahrenheit, but his is the best. And he was justly famed for this result. He's also somewhat famous for saying this: when you cannot measure whatever it is you're talking about, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. A lot of scientists, especially physicists, would agree with that. But at the same time that he was running his experiments and publishing his paper, there was a man in a little village or hamlet or rural place outside of London who was Charles Darwin, who was in the process of spending 9 years writing 2 books, each in 2 volumes, on the topic of barnacles. One was on living barnacles and one was on the fossil barnacles of England. So he spent 9 years working on this. And there are lots of pictures and drawings of barnacles. Another scientist, Rutherford, said, all science is either physics or stamp collecting. This is like the ultimate stamp collecting science. This looks like a stamp album. Now, I've skimmed very quickly through the first 300 pages of the first book, and there are very few numbers in those pages. There's a table in the first 300 pages that compares the lengths of little things all barnacles have across several species, but there is nothing like the graph that I showed you before. So, what's going on with Darwin here? Why is he wasting 9 years of his life drawing pictures of barnacles and writing the most painstakingly detailed description of species after species after species of barnacles. Everything in the 300 pages is, here's another species of barnacle. Its thingy is wavery and 8 centimeters long or whatever, as compared to this thing where its thingy is not quite that long, et cetera, et cetera. So it's just endless detail about barnacles. So that looks like a huge waste of time, but he never had a real job, so what? He can waste his time. But what he was doing was something very interesting. So Darwin's study of barnacles was a highly theoretical work that addressed several problems at the forefront of contemporary natural history. So he was a natural historian. That's what they used to call biologists, or we now call people like him a biologist. And biologists have the problem that there is a enormous, incomprehensible amount of variety and detail in the world of living things. And biologists have the problem of how do you categorize, how do you condense, how do you simplify all this detail into some structure that the human brain can begin to work with. And at the time Darwin was, at this time, around 1848, there were various theories that said, how do you define, here is how you should classify animals or classify species. Here is how you can tell whether one species is closely related to another or if it's very different from the other. And there were opinions about this. Darwin used this study, these 9 years, sort of bashing the theories against the reality of a very complex business domain, which was barnacles. So he was testing those theories to find out how to organize barnacles. And this had three key effects. One is he demonstrated a particular way of classifying things works pretty well. The other thing it did was, at the end of this, Darwin became an extremely well-respected member of the biology community. This was clearly a guy who knew his barnacles and had demonstrated that he was meticulous, thorough, precise. If he said something about, say, barnacles, you could pretty much trust that that was a true thing. This came in handy later because at the time that Darwin was working, a lot of people accepted the fact that there was evolution among species over time, but the question was, what was the possible mechanism? And Darwin's big advance was claiming a possible mechanism for evolution. And the fact that he was well known to be somebody who was data-based meant that when he made his claim, people were inclined to accept it. This is not like a software consultant who's worked on only four projects in his entire life, and thus makes big sweeping claims about the way software should be done. This is a guy who knew his stuff. And the final thing is this barnacle work also provided evidence for the mechanism that he proposed for evolution. So this is really cool stuff because you've got theory that's applied to data, that produces results, that is used as the justification for a new theory. This is science. This is not meager and unsatisfactory. Sorry, Kelvin, sorry, physicists, but you're not the only science and you don't get to make all the rules. Because it is the case that different sciences have different subjects. Physics is a subject where early generalization is typically rewarded. Natural history is a subject where early generalization doesn't do you much good, where you really have to look at the details instead of stripping off the details as you would do when you're doing a physics experiment. And so a result of that is that different sciences have different ways of producing reliable knowledge. Astronomers don't do experiments, but they produce reliable knowledge. Now, when it comes to our people, academics who are working in the area of software, how to do software, generally you've got two kinds of work that they do. One is sort of modeled after experimental philosophy. You get a group of people, divide them in half. One half does TDD, the other half doesn't do TDD. In the worst case, all these people are students who don't know what they're doing in the first place, and they're only doing it for a month because you can't spend 5 years, keep a student for 5 years, but a lot of them are done well. And the idea is that you gather data and you crunch the numbers, you do some statistics, and you get the magic if you get the magic number p less than 0.05, publish. The other kind of thing is you might have a hypothesis that something about open source projects. GitHub has a whole lot of open source projects. They've got an API that lets you make queries, so you can query GitHub for the information you're interested in, or for information you can argue is correlated with the thing you're interested in. You swoop all that data in, you do summary statistics, and then you can say 50% of all open source projects do this, which has sort of the implication that that's a good thing to do. So I think this is fine. I think this is really, really hard to do well, but I think it's fine to do. But I think that we should also follow Darwin's approach, because I think our area of work has more in common with the situation biologists are in, that is to say, a lot of data, than it does the way physicists have it. So, what I want to get out of this is I want to have a scene that is about doing Darwin stuff to our kind of barnacle, the variation that we have. And the kind of barnacle we have is the experience report. We have, we tried mob programming for a year, and we came to the following conclusion. That's information. Or we're Rust. You've heard of us. We're a popular programming language. This is how we handle the flow from pull request through approval to distributing among all of our build servers. And so people look at this sort of thing and they say, I wonder if we should do it that way. Now, what they are typically missing is context. Typically, experience reports do not provide enough context for you to really know if it's applicable to your situation. And people don't naturally ask for context. The company I was working at, I mentioned the Rust write-up to them, and one person's reaction was immediately, we should build this tooling, and no, this is actually only 15 people, and it's all in one company. People need to be trained to produce better, to demand better context. My solution to the problem of people not demanding context is on the supply side. I want to provide better context. I want to provide context that is of the level of detail of Darwin's description of barnacles. And I'm sort of taking as inspiration my wife, who inspires me in many ways. One of the ways is writing papers like The Effect of Colostral Volume Interval Between Calving and First Milking and Photoperiod on Colostral IgG Concentration in Dairy Cows, a paper that I'm sure you will all rush out and read. If you read that paper, what you'll see is a section which is very common in many fields. It's a materials and methods section, and it says in detail the context of her experiment. Supposedly in enough detail that if you wanted to repeat that experiment, you should be able to do it independently from this. And that's very similar to the problem of describing the context of the Rust build system. And the fact that it's a special thing that every paper has to have encourages the culture to produce such things. So I think we need context presented in a relatively rigorous form, something like this. As Don has occasionally reminded me, cows are not like people. Generally speaking, cows are more pleasant than people. The philosopher Gilbert Ryle, so people are different from cows in that people attach meaning and interpretation to what they do. The philosopher Gilbert Ryle described the kind of things you'd see in a materials and methods section, the kind of things that are observable. An outside observer can come and look at things and say, they give this much drug to these animals at this time. He calls that thin description. There's a different kind of description called thick description, which I learned about from this book by Clifford Geertz, which is a book that created a new kind of anthropology. Thick description is, in addition to describing the observable facts, you also describe the meaning that the people creating those facts assign to that work, and all the meanings and interpretations that they use to create things that you can observe. As an example of this, I was having a kind of heated discussion with someone about how to handle pull requests in projects. And the way he wanted to handle pull requests, I thought, this is incredible. This is very heavyweight. I want to merge onto trunk and this. And I didn't understand what on earth he had in mind until he said something that the problem he was trying to solve was sociopaths, his word, making pull requests with the aim of damaging the project. Blockchain. That's not, so the meaning he attaches to the word pull request is way different than the meaning I typically attach to pull requests, and so I cannot evaluate his system of handling pull requests until I understand the meaning behind it. So that's context. I'd also like to see more careful vocabulary. That can mean two things. One is it would be nice if all of us use the same terminology for the same thing, but I'm actually more worried about the case where all of us use the same terminology for 8 different things, like these things. If you ever use these words, it ought to be a law or an EU directive that you're not allowed to use these words unless you write at least a sentence explaining what you mean by technical debt. Okay, and the final thing that I want to get out of this is charged concepts. This is a bit on the vague side. This is a term related to a term that Collins uses. I like the term charged concepts because it's got that electricity to it. So, like, if somebody with hair were to rub a balloon on it, you could rub their, charging a balloon with static electricity. You can attract hair and bits of paper to the balloon. A charged concept attracts people the way that balloon attracts hair. Similarly, when the people are involved in a charged concept, that gives them energy, it charges up their batteries, etc. So, as an example of a charged concept, for Darwin, embryology was a powerful charged concept. We should think about the embryo stages of animals, not just the adult stages of animals, when we're making classifications. The Agile Manifesto is essentially a list of 4 charged concepts. When I was actually doing Agile coaching, working software was something that teams needed to define for themselves. They needed to talk and argue about what working software was and how they were going to achieve it. The need to achieve working software led to things like continuous integration. It led to, arguably, DevOps. It led to the ideas of testing and monitoring in production, or at least it was a part of those ideas. So these things produce lots of powerful ideas when people are attracted to work on them. In the case of punk, there was a charged concept called do it yourself, which basically said, don't use experts to do something for you. The community and individual people should do it themselves. So, kind of famously, people would decorate their clothes and make their own specific clothes, or at least put the zippers and safety pins in different places on their clothes to avoid having to go outside to have an expert record your album. You record it yourself on cassette tape. Instead of having a record company press the album, you distribute it on cassette tape, because the technology was at a point where tape duplicating machines were readily affordable. Do you use the big music magazines to advertise yourself? No, you use fanzines that are photocopied and stapled, and you don't use the record company distribution network. You say, send $3 and postage, and I will ship you my album. Now, of course, punk did also work with the record industry, but this was in some way the ideal. And I think it's interesting how this simple idea, do it yourself, ramifies out into all these consequences. And that, I think, is a characteristic of a charged concept. So now I'm aware of the fact that you can't even get people who give talks to write their talks down most of the time. We're not going to get them to write a materials and methods section. We're not going to get them to stop saying technical debt without defining it. If we want this to happen, we're going to have to do it ourselves, which means you have to do it. I want people like you to be part of the scene, the barnacle scene, that will be taking knowledge and making it into more reliable knowledge. And I am willing to help. Everybody likes that, isn't it? Well, it's a great idea. I'll do that in every talk from now on. I spent 7 years as a technical editor, half-time. I'm a pretty good editor. Only 2 people in those 7 years ended up hating me. Lots more ended up liking or loving me, and I have a considerable amount of experience technical editing, people who have never written anything before. I would shepherd them into their first article. So I'm making myself available as editor for this, and anybody who wants to participate in this will get a t-shirt with a barnacle on it and the word context. One person likes it. Okay. I may have to actually do it instead of using a Photoshop type tool to produce it. There's another thing I want to do, which is also a bit of a digression. In other fields, there is the idea of a survey paper. If my wife, who does not work on dairy cattle nutrition, wanted to know something about the role of protein in the diets of dairy cattle, she could go to the Journal of Dairy Science, and in some back issue of it, there would be an article written by one of the biggest experts in cattle nutrition, and that article would be, "Here is everything we know about dairy cattle nutrition," summarized with links to everything else. Contrast that with what we've got, which is, I was looking at a paper that talked about doing one of those psychology experiments, I think it was, on pair programming, and they defined pair programming with reference to Extreme Programming Explained, a book that I believe was published in 2000. Now, I think that pair programming has actually changed in the last 19 years, but because there's no survey article describing what it is at a point in time, hapless academics, like my wife might, if she were writing an article on pair milking, and for whatever reason she wanted to reference pair programming, she would probably end up at the XP Explained because there's no other place to look. And it'd be worse if she were trying to do pair programming. So there's a lot, I think, survey papers have a lot of interesting characteristics and interesting ways in which they advance the field. I'm not going to talk about that again because of time. Final thing that I want to say is, because human beings are, we're three-dimensional creatures, and we move around in space, and it seems to be a characteristic of human beings, from my study of the species, that they like to have a place they can call their own. CBGB's is one of the two clubs that was the place to go for punk rock. It was the place that that woman was so excited to go into. This is what remains of the Plato's Academy, which was where the Plato scene happened. This is where Plato and his various disciples and students all got together to do what you might call the Platonism scene, or a philosopher would call it probably something like the Platonic school. Now, because humans are good at metaphors, we tend to think metaphorically, we can associate that need for a place to be called home with places that aren't actually physical. This is an old screenshot from 1996 from the C2 Wiki, the very first wiki ever created, which was created to collect patterns and evolved into the place where written discussions of what was not yet called Agile happened. So if you go there, it still exists, though it's frozen. If you go there, you'll find an argument between me and Ron Jeffries on test-driven design, in which it took me a long time, but he turned out to be right and I turned out to be wrong. But these arguments happened. And I think that any scene needs some sort of metaphorical space. So I registered a domain called the libraryofcontext.org. And that's actually all I've done. I did it just before I left for this trip, but I want to make this into the place for people who care about the stuff that I am talking about here. Now, as you might be able to tell, I don't have a great visual sense of style, and certainly I'm not going to have much luck if I try to do either UI or UX on this site, so I'd appreciate help for that. Okay, so the stirring conclusion. I always want to have a stirring conclusion, and I never do, so I have to put it on the slide so you know you're supposed to be stirred. These are thought-provoking books. I recommend reading them if you're interested in this kind of thing. Collins is a scarily thick book. It's like 800 or so pages, but only about the first 150 or 200 have the theory. The rest is a Darwin-level description of the history of Greek philosophy, the history of Indian philosophy, the history of Chinese philosophy. So that's all the data that he uses to justify his conclusions. So I just wanted to warn you about that. So I like these books. They're not like beach reads or anything, but they're not bad for academic type books. I'd like to see what we've got in terms of all of these experience reports, all of this not so reliable, not so contextualized information. I'd like to build it into a better scene. I can do a lot of work because I am old. My wife is now an emeritus professor. We have enough money to live comfortably until we die. I have nothing better to do, so I can do work here, and the field can exploit me with a clear conscience, but I'm not going to do this work unless I get help. Okay, so that was the stirring conclusion. Now it's time for questions. For some reason, my talks don't tend to provoke a lot of questions, and then there's that uncomfortable pause. So I've given you some questions that if no one has any real questions, could somebody ask one of these? No, the real question. Do you have a real question?
Yes, I do.
Okay. So here are books. And here comes the laser light pointing out the academic in the room. No, they're like cockroaches. If you see one, there's a lot. The question is this, am I targeting this toward academics? Fair enough? I am not targeting this to academics. I have I used kind of all this academic examples because those are the people doing science. But remember, science in Darwin's time was sort of a spare time thing done by a lot of, like Lord Kelvin had spare time to do science. I want this science to be primarily practitioner-driven. If I could get academics interested, that would be great. But one thing we learned in the patterns movement is if it doesn't look like science and it doesn't look like original work, it's not going to get accepted for publication, which means it's 10-year suicide to attract it. So I don't expect to attract academics. In the back.
Do you feel like
Do you feel like sciences about computer practices and methodologies are right and like in the science way of doing studies, or does it look like more pseudoscience?
Well, the answer is I don't know. I didn't end up using much information from the theory and reality book. That's an introduction to philosophy of science. I used to be really interested in philosophy of science around 2000, and there's actually been a fair amount of what seems to me to be progress in philosophy of science. I will answer your question. For the philosophy of science has really been around for about, I'm going to date it back to Karl Popper, 1920s or so. And what people were looking for in philosophy of science was one weird trick that is science. That was what Popper did. That's what Lakatos did. And they were looking for certainty. They wanted a clean way to distinguish between science and non-science. And if I believe this book, philosophy of science has broadened it. It is thinking of science as a complicated thing. For example, there are characteristics in common between different sciences, like the idea of exposing theory to evidence, bashing your ideas against the actual world. And there are social structures of science and so on and so forth. Whether this is science or not, I don't know. If it works out, maybe it'll become respectable, but I don't know if I care about it being something that you can fit in the box called science. Sorry, that was kind of a rambling answer. Is that a stop? Okay. So I can actually talk about all of these things. They're interesting stories. I will go float down to the open spaces type room, and if anybody wants to get a t-shirt, you can come down there. Thank you.